Chapter 8 was spent factoring polynomials, and we actually worked most with quadratic functions. Remember, quadratic means that the highest degreed term is a 2. And now this first half of Chapter 9, we're going to be working with identifying quadratic functions and looking at a lot of things graphically. So by the end of this lesson, I want you to be able to identify a quadratic function and determine whether it has a max or a min, and also graph a quadratic function and be able to give its domain and range. So the first definition is a quadratic function. This is any function that can be written in the standard form y equals ax squared plus bx plus c, where a, b, and c are real numbers, and a does not equal 0. We have factored quadratic expressions, so now we're working with functions, so we want an equation. That's why we have the y equals. So when we look at some functions and we're trying to determine if they're quadratic, we need to see if it can be written in y equals ax squared plus bx plus c form. And remember, the rules for a, b, and c are that they are real numbers, and a cannot be 0, because if a is 0, then your squared term goes away. So if we look at number 1, it's f of x. Remember that f of x is just a function in terms of x, so that's the same thing as y equals. But the number 1 equals 3x squared plus 6x minus 9. So if we look up here at our standard form, it does look exactly like that, where the a would be the 3, the 6 is b, and negative 9 is c. So yes, it's a quadratic function, and if you were to have to explain in your notes or on your homework, you would say it can be written in the form y equals ax squared plus bx plus c. So if we look at number 2, we have y equals 7x minus 12. And hopefully the first thing you notice is that there's no x squared term. In order for a function to be quadratic, there must be an x squared term. So this is not quadratic, and it's because there is no x squared term. This is actually a linear function. Think way back to chapter 5. Number 3, we have g of x equals x squared minus 9. Again, g of x, f of x, any variable of x is the same thing as saying y. So we have x squared minus 9. Now here you may notice there's no x term. There's no bx term in the middle. But that's okay. We don't have to have the x term. What we have to have is the x squared term. So here, your a would be 1 because it's the number in front of x squared. Your b would actually be a 0, and your c would be negative 9. And you're not asked to write that, but yes, this is a quadratic function. Because if we were to rewrite it, we would say x squared, we could say plus 0x minus 9. And then it looks more like standard form. And of course, we would also say g of x equals. Number 4, we have y minus 10x squared equals 6. And again, if I write standard form at the top, ax squared plus bx plus c, you'll notice that the x squared term is over with the y, but that's okay. We can just add it back to the other side. And so if we were to write this in standard form, we would have 10x squared. Again, we don't have a b term, but that's okay. We could write 0x plus 6. So yes, it is a quadratic function because we can write it in standard form. On number 5, again, f of x equals 2x squared minus 2x. So here you may be noticing that there's no c term, but we could always write a plus 0 on the back, so our c would just be 0. So again, this is a quadratic function because it can be written in standard form. So now let's talk about what the graph of a quadratic function looks like. And it's called a parabola. A parabola is the graph of a quadratic function. It is a U-shaped curve. So if we look at the 4 examples here, and you don't need to draw those, you may draw 1 or 2 if you'd like, but they don't have to be perfect, just so that you know what shape a parabola is. Notice that they are U-shaped. And it's very important that you don't try to draw them as V-shaped. They are not V-shaped curves, okay? They're U-shaped curves. So here are 4 examples of what a parabola looks like. So if you're given a graph, we want to know if the following graphs are quadratic functions. And you need to be able to explain. So number 6 is yes, it's U-shaped. Number 7 would be no, it's not U-shaped. And in terms of the parabolas that we discuss, number 8 is a U-shaped curve. And we talk about parabolas that are y equals ax squared. Because 8 is U-shaped, it is technically a parabola, but it's not a type we will talk about. We won't talk about types that open to the left or the right, because these are actually parabolas that are x equals y squared, and we won't talk about those. But technically 8 is, yes, a parabola. So now we can identify quadratic functions based on an equation or based on a graph. Now we want to talk about all of the different pieces to the graph of a quadratic function, because there are a lot of them. The first vocab term is vertex, and the vertex is the highest or lowest point on the parabola, and it's written as an ordered pair. So you can see I have 2 parabolas drawn on the graph. The vertex is that ordered pair here on the left that would be the highest point on the graph. And on this parabola, it would be the lowest point on the graph, because it's all the way down at the bottom. But those are the vertices of parabolas. It's either a high or a low point. So let's identify some vertices. Identify the vertex of the parabola. On number 9, you're simply naming this ordered pair. So it's 3, 2. That's how we name the vertex. You try number 10. What would be the vertex of this parabola? Hopefully you're saying 2, 5. Identifying the vertex is pretty simple if you've got it graphed. Now we want to talk about the max and the min, and it relates to the vertex. So the maximum is the highest point on the graph of a downward opening parabola. It's also the y value of the vertex. The minimum is the lowest point on the graph of an upward opening parabola. It's also the y value of the vertex. So the max and the min, if I ask you to locate the max and min, it would be the y value of the vertex, and it's either the highest or the lowest point based on if the graph has opening upward or downward. So we want to identify the maximum or the minimum, and you also need to tell me if it's a max or a min. So on number 11, if we look at this, because it's downward opening parabola, it opens down here, this is going to be a max. It's the highest point on the graph, so it's a max, and we need to know where it is. Notice it's the y value, so it's a max, and it's y equals what? What's the highest point on this entire graph? Well, we go over to the y-axis, and we see it's -3. So the max is at y equals -3. Number 12 then would be the opposite. This would be a min, or a minimum. Notice it's the lowest point on the graph. So here we have a minimum, or a min, and you have to determine where it's at. Remember, it's either the y-coordinate of the vertex, so you could name the vertex here, or you just go over to the y-axis and you see that it's at y equals -4. Okay? Notice I'm writing y equals -4. I don't want you to just put -4. You try 13 on your own. Let me know if it's a max or a min, and then tell me what the value is of the max or min. Hopefully you're saying that it is a maximum because it's a high point on the graph, and it's located at y equals 3. We come over to here and we're looking, where's that highest point on the graph? And it's at +3. Last, we want to talk about the opening of a parabola. You can tell if a parabola opens up or down simply by looking at the graph. In the last 3 examples, we can see that this parabola opens downward, the second one opens upward, the third opens downward. But you can also tell by looking at the equation or the function. So first you have to make sure that it's written as f of x equals ax squared plus bx plus c. But it's going to open up if the a, notice it's the coefficient in front of the x squared, is greater than 0. And if it opens upward, it's going to have a minimum. It's going to have a low point. If the parabola opens downward, then the coefficient in front of x squared, that a, is going to be less than 0. This opens downward, and it's going to have a maximum value. So let's determine whether the graph is going to open up or down. Number 14, we have f of x equals negative 4x squared minus x minus 1. The negative 4 is where we're focusing, the number in front of the x squared. It is negative, so it's going to open downward. Number 15, we have y equals 5x minus 3x squared. Now notice it's not quite in standard form. You're looking for the x squared term, and you're trying to find the coefficient in front of it. If we were to rewrite this in standard form, we would say negative 3x squared plus 5x. That negative 3 is where we're focusing. This also opens downward. Number 16, we have y minus 1/2 x squared equals 3x plus 6. Again, we're not in standard form. You may focus on that x squared and see that it's negative and be inclined to say that it opens downward. However, we have to add that term back over to the other side so that it's in standard form. That's going to give us y equals 1/2 x squared plus 3x minus 6. Now you can see that that coefficient, or that a that's in front of the x squared, is positive, so we open upward. Go ahead and try 17 and 18 on your own. 17, we have a positive 2 in front of the x squared, so it's upward. And similar with 18, you're looking for the x squared term, and it's back here, and it has a 1 in front of it, an implied positive 1. So this one also opens upward. Now the last thing we want to do is kind of put some things together, but we want to be able to graph a quadratic equation using a table of values. Later we'll learn how to graph without the table of values, but we also want to state the domain and the range. So when we graph a quadratic function, we are picking the x values, we're plugging them in and trying to find y. You can pick whatever values you like. I like -2, -1, 0, 1, and 2. So when we plug in a -2, remember you're squaring -2. -2 times -2 is a positive 4. We plug in a -1. -1 squared is positive 1. We plug in a 0, we get 0. 1 squared is 1, and 2 squared is 4. So now we need to plot the ordered pairs. -2, 4. -1, 1. 0, 0. 1, 1. And 2, 4. Remember, these are U-shaped curves, so don't make them V-shaped. Try to give them a U shape to them. Okay, there's a parabola. So we've graphed number 19. We want to state the domain and the range. What's nice about the domain for a quadratic function is it's always the same. The domain is going to be all reals. Remember, the domain is the x values. So basically, what x values could you plug into this function? You could plug any x value into that function. So every x value is included in the quadratic function, so we say all reals. The range is where we want to focus on, again, that low point or high point on the graph. The range deals with y's. And we're looking for the lowest or the highest point on the graph. Notice this graph continues upward forever, so we want to find that low point we want to find the vertex or the minimum. So we're here at 0. So we know it's going to be y and it has to deal with 0. The question is, are we talking about y values greater than 0 or less than 0? And you can see the graph is greater than or equal to 0. So the range is y is greater than or equal to 0. Let's graph 20. And I want you to be very careful here when you're picking your x values. I'm going to pick the same, -2, -1, 0, 1, and 2. What you have to be careful of when there is a negative in front of the x squared, because we don't have any parentheses, you need to square the number first and then change its sign. That's what that -1 out in front does. So if we square a -2, we get a +4. But then we need to make it negative. So that's actually -4. -4 plus 6 is 2. If I plug in a -1 and I square it, I get a +1. But then I have to make it negative because we're multiplying by a -1, so we get -1 plus 6, which is 5. We plug in 0, 0 plus 6 is 6. If I plug in a 1, again I square it, I get 1, but then I have to make it negative. -1 plus 6 is 5. And when I plug in a 2 and square it, I get 4, but I make it negative, so -4 plus 6 is 2. And you may be noticing a pattern here with our y values. Notice it goes 2, 5, 6, 5, 2. Similar to the last example that went 4, 1, 0, 1, 4. So now let's graph these again. -2, 2, -1, 5, 0, 6, 1, 5, and 2, 2. We want to connect our dots and make it look as U-shaped as possible. When you're dealing with a quadratic and you're graphing it, if you find the vertex, in this case it's that 0, 6, the points on either side of it are going to have the same y values. But you have to make sure you find that vertex. If you don't find the vertex, it won't work like that. But if you find the vertex, the points should be mirror images of one another. So the domain, we have all reals. For the range, again, we're looking for that high or that low point on the y-axis or in the y direction. So we see here we have a maximum, and it's up at 6, all the way up at +6 on the x-axis. So we're talking about y and we're talking about 6, but now are we talking about all the values greater than or equal to 6 or less than or equal to 6? Notice that since this parabola opens downward, we're talking about all the y values that are less than or equal to 6. So we have 5, 4, 3, 2, 1, 0, and all the way down into the negatives. Again, this graph does continue on forever, remember. So all those y values would be included. For number 21, we have y equals x squared minus 2x minus 3. This is maybe one of the first times where you've graphed and you've got an x in more than one place. So whatever value you pick for x, you have to make sure that you're plugging it in here and here. So for the first x value, let's just pick -2 again. So be very careful what this does. We have -2 that's being squared minus 2 times -2 minus 3. So -2 squared, that's 4, minus 2 times -2 is -4, so minus a negative would be +4, minus 3. So 4 plus 4 is 8, 8 minus 3 is 5. Let's pick -1. If I plug in a -1, I'm squaring -1, minus 2 times -1 minus 3. So -1 squared is 1, minus, excuse me, 2 times -1 is -2. So minus a -2 is actually +2, and then minus 3. So 1 plus 2 is 3, minus 3 is 0. Now I'm going to plug in a 0. That's the easiest one to plug in. When I plug in a 0, this is 0 and this is 0, and I just get -3. Now I'm going to plug in a 1. 1 squared is 1, minus 2 times 1 is 2, minus 3. So 1 minus 2 is negative 1, minus 3 is negative 4. And now I want to plug in a 2. 2 squared is 4. 2 times 2 is 4, minus 3. So I get 4 minus 4, which is 0. 0 minus 3 is negative 3. So it's a little bit of work to find those y values. But let's plot them. Negative 2, 5. Negative 1, 0. 0, negative 3. 1, negative 4. And 2, negative 3. And you can see here this doesn't quite look like a parabola, but hopefully you noticed that down here we probably have our vertex. So if I would have picked another point, notice that they are mirror images of one another. If I had picked another point, it probably would have been 0 or 3, 0. And then also if I'd picked another point, the fourth point, if I'd have plugged in a 4, I probably would have been up here. So you can see that parabola shape take place, but I didn't have all those points on there, and that's okay. But when you draw your parabola, you still need to make it look as U-shaped as possible. So there you go. The domain again is all reals. And in looking for the range, we're focusing on the y value. It's either a maximum or a minimum. And here we have a minimum. We're down at negative 4, but we're talking about all the values that are greater than or equal to negative 4. We've done 3 graphing examples now with domain and range. There is a 4th example here if you'd like to try to graph that one. I can check it for you when I check the notes. But you don't have to do this one if you feel confident in graphing the quadratics. So we covered a lot of material today. We looked at vertices for parabolas. We looked at how to tell if a function or a graph is quadratic. We looked at maximum and minimum values. We looked at the opening, how to tell which way a parabola opens based on the function. We did some graphing, and we talked about domain and range. So there'll be a really good worksheet tomorrow in class that will focus on all of those pieces.